Hello and welcome. Here we have example 526, and Mohammed is going to receive a 4-year annuity of $500 per year beginning at date 6. If the interest rate is 10%, what is the PV of this annuity? And what I have here, just for convenience, is the present value of an annuity formula. However, I'm going to argue right now, let's not overcomplicate it. Let's ignore this entirely right now. Let me just push it to the side. I don't even know if I'm going to use it. Um, Hopefully we can recognize this is an annuity. I mean, I know that it says the word annuity right in the problem, but it's a stream or series of payments, and those payments are of equal value, $500. So hopefully we recognize this is an annuity right off the bat. What I'm going to do is work a little bit backwards first, and not treat this as an annuity right now, but just to introduce a concept. I'm going to just say maybe this person has $500 and they're wondering what $500 will be in 1 year from now. All right, so and assume the interest rate is the same, 10%. All right, so this is a problem that we can probably all work with quite intuitively, and we would know what to do. We have $500 growing at 10%. If I were to calculate this, I would type 500 times 1 plus the interest rate, which is 10%, so 1.1, and I'd have $550. If I were to discount this $550 back to the present value, I would take my future value, which is 550, and I would divide it by 1 plus the discount rate, which is also 0.1. So future value divided by 1 plus the discount rate. And I get back to that $500. So that's an example of present value, future value of a single amount. And we have the formulas here. Now, this is just one period, so it's a little bit simpler. But I'm going to keep these formulas here as background as I answer this question. What I'm going to do is structure this as a timeline. So I'm going to put like my time as my top row, starting in period 0, and how far do I need to go? I don't know exactly. 4-year annuity beginning at date 6. Okay, so the first payment here is in time period number 6. And maybe I'll just center and bold my timeline here. And it's $500 as my first payment. So here in my second row, I'm going to write cash flow. So everything in this row is the cash flow associated with each period. So in period 6, they get $500, but it's an annuity of 4 years. So there's going to be 4 payments of $500. So 1, 2, 3, 4. So it actually goes only until period number 9. Now what I'm going to do in my next row is put discount rate. And what is it? 10%. So I'm just going to write 10% and copy and paste that 4 times. Now with this setup, all I need to do is calculate what the present value of the cash flow is. And I'm going to be using this formula here, exactly, where I have my future value, and I'm going to divide it by 1 plus the discount rate. The only thing I'm going to add onto this formula is I'm going to put it to the power of what time period that we are in, because that is the number of periods that I need to discount. So for example, right here, if I want to figure out the present value of $500, my future value is 500. So future value divided by 1 plus the discount rate, which is 10%, to the power of 6. So this is going to give me the present value of $500 in 6 years from now. So present value of a single amount. And now I can just copy paste this all the way across. And if I want to know the present value of this annuity in time period 0, I'm just going to sum together those 4 amounts. And I get $984.12. as my present value of this annuity. And I didn't need to have this complicated formula at all. I just needed to know basically that the present value of something is the future value divided by 1 plus the interest rate and then to the power of n. And you can see here I've got power of n as the header essentially of my timeline. So that's probably the simplest way of going about a problem like this. Alternatively, what we could do is use our financial calculator or the equivalent functions in Excel. Now, so let me maybe put this as a border, thick border, isolate it. I'll call it like method 1. Method 2 down here would be perhaps through the present value function that is in your financial calculator or in Excel. The financial calculator, you have your time value of money row where there's 5 variables. And you're typically given 3 or 4 of those. And it's just a matter of typing into your calculator what you actually need. In Excel, you can type equals PV and you get the arguments that you need or variables. So PV, rate, and per, and payment are what we need in order to calculate the present value of something. So here, assuming I know absolutely nothing, if I just type PV, I know I need rate and per payment in order for this function to work. So all I'm going to do is type PV, PV, rate, and per payment. And it would be a similar process on your financial calculator. I'm here trying to calculate the present value. The rate is given 10%. The number of periods here is what is confusing about this because it's a 4-year annuity. So the annuity itself is 4 years. So my number of periods must be 4. There are 4 payments associated with this. So that's what that is referring to in your financial calculator or in Excel, number of periods, or just N on your financial calculator, is how many payments are there. And there are 4. And the payment is $500. So what I can do now is type equals PV and just pass it these arguments. So rate, N per, and my PMT, my payment. And I get this 1,584, which I know is different than what I had just calculated. But this is the present value of 4 payments. And these 4 payments begin in period 6. So this is basically the present value at period 5, because we would be discounting all 4 of those payments. So I need to go from 5 to 4, 3, 2, 1, 0. I need to discount this 5 more years. So I have a choice on how I want to do this now. Basically, what I could do is do the PV function again and say, well, my rate is this. My number of periods is I'll just type 5. My payment is 0. And because I'm now just doing the present value of this like lump sum present value, and my future value is here, and I should get something that is very similar to this 984.12. So maybe I'll just specify that here is the answer. Alternatively, what we could do is just reuse this formula that I had introduced at the very, very beginning. So my future value, and here I'm just going to do negative just to keep our signs consistent, and divided by 1 plus the discount rate, 1 plus 0.1 to the power of 5. And I should get exactly the same number. So there we have it. So that is example 5.26. I hope that you found this useful. If you have any questions, please feel free to reach out.